most of what I do is sort of connected to this idea of machine learning for artists. So I'm interested in applications of machine learning for art. And it's something that I'm not going to talk about very much today, but it's kind of tangentially connected. And I'll kind of make a few, interweave it a little bit towards the end. What this talk is going to be mostly about is this notion of decentralized artificial intelligence, or decentralized AI, which is something I've been thinking and writing about a lot recently. For me, I've been really invested in machine learning for a long time, and sort of decentralization stuff is a lot newer for me, but I'm quite excited and also nervous about the intersection of these two things. There's a little bit of like a sort of double buzzword syndrome happening here, where the two things are like very sort of hot topics, and so it can be very hard to, if you're interested in how these things intersect, it'd be very hard to disentangle things that are actually interesting about it from this sort of like hype train that you see in both of them. So I'm going to do my best to kind of like try to focus on real things. So let's get into it. So in some sense, this is kind of two topics in one, and I'm going to explore their intersection towards the end. I'm going to talk mostly about like kind of start out talking about machine learning and then talk about what happens when you add this notion of decentralization to it. And just to kind of be clear about a little bit like what I'm specifically talking about. By decentralization, I mean technologies like blockchains and cryptocurrencies and tokens and DAOs, all this kind of stuff that we see a lot of these days, trying to disrupt this and that, every industry that it can. And then on the other side, you have machine learning, or AI, deep learning, and applications that it has to natural language processing and computer vision and so on. And these two things, I'm going to talk about like why they're important to each other. So that's actually the next slide. So first of all, like why is the notion of decentralization relevant to AI? So for the most part, if you read like popular media and press and things like that about deep learning and machine learning, you'll mostly get a lot of news about like things that sort of interface with human beings, right? So robots and chatbots, and recommender systems and self-driving cars, and Siri and Alexa and Cortana and all this kind of stuff, right? But and this soaks up all of the press with AI, and it should make sense why, right? Because it's the thing that we find most exciting. Like people want to know what AIs look like in front of them, how they interact with them, right? But there's kind of a problem with this coverage, which is that it doesn't necessarily focus on those applications of machine learning which are actually very, 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 very close, very, very happening now, that are realistic. I mean, of course, like we see basic versions of these already in production, but they are kind of really, really simple versions of it, right? So like, Siri and Alexa have very limited intelligence. They can tell you the weather, but they can't, they can't necessarily do very much for your day-to-day activities, right? They're just kind of like advanced Google search, right? And the reason for that is twofold. One is that there's this, before it does any of the actual interesting work, it has to first understand what you're saying to it, or how you're interacting with it, and that what we call human-computer interaction. And that's really actually quite difficult, because humans are very, very inconsistent and capricious, and we have many, many languages, and we have slang and idioms, and culture is very, very sort of complicated and hard for computers to understand. What computers understand much more readily are computer protocols, right? Things that are very rigid and consistent and work the same way all the time. And so for that reason, applications of machine learning that are relevant to computer interaction are actually much more close. And a lot of them, of course, are already actually in production. So if any of you use social media, I assume that most of you do, you know that these days, basically all content that people are exposed to on the internet on a daily basis is completely and entirely selected using machine learning algorithms. And that's an extremely huge shift from the way that we consume news and, current events and things like that, from just even 5 years ago, I think, I would say. And then there's this also, why are AI and blockchains relevant to each other? So for AI, what it gives to the decentralization space is the ability to carry out complex behaviors, right? Because most of what we, starting with Bitcoin and on out, most of the applications that we really think about with blockchains tend to be very simple. So exchanging money, or kind of like, they're all variations of that for the most part right now. They're all basically financial applications. That's growing a little bit, but they're still pretty simple. And what AI can give to decentralization is complex behavior. So the ability to adapt to situations as they change, and to just generally act more intelligent, right? And on the other side, what decentralization technology gives to AI is this notion of autonomy, right? So if you think about artificial intelligence, right, we usually associate it with things that we can control, right? But like, we can't control other intelligent beings. Like, you don't turn an animal on with a button, right? It's autonomous, right? So autonomy is actually, to me, I think, a very, very crucial and necessary component of any intelligent system. And with blockchain and other kinds of decentralization technology, not just blockchain, we have the ability possibly to create systems that exist beyond the ability for us to turn them on or off. They're truly autonomous and sovereign, and they have their own computational resources and their own value resources and so on. And so AI has the, can benefit from that, you might say. It wants that, right? So the first part of this, I want to get into like more about machine learning and deep learning, and then we'll kind of like work our way back to decentralization stuff. So we'll kind of start talking with this, and then loop back to decentralization. So machine learning is this field, kind of a subset of artificial intelligence, which has existed for a few decades now, and it basically is concerned with learning functional models based on data combined with a learning algorithm. So like a really simple version of this is a system which will look at an image of a number and then tell us what number is in that image, right? So like image classification is a very, very core task in computer vision, right? And most of the time, like we're gonna take a very high level view of this. So we're not gonna talk in too much detail about how these work today, but just everything that kind of we'll talk about depends on understanding this in the following sense: that what you have is a function which takes in some input, which can represent some real world object, let's say, and outputs something that is meaningful or interesting to us. So what it is, or a description of it, or perhaps another image, or lots of sort of more complicated, possible sort of input outputs. And let's kind of consider this in the context of computer vision, which is where it's had the most success in the last decade or so. This is how computer vision worked in the 1990s and 2000s. And even for me, like when I first got interested in machine learning, which was maybe 10 years ago, computer vision basically looked like this. If you were interested in image classification, like detecting objects inside of images, you would have to do all this sort of pre-processing where you would apply some well-known heuristics or algorithms for feature extraction on the image. Like, for example, this is what you're looking at are called Hog features, so histogram of oriented gradients. This is just kind of like divides the image into a bunch of segments, and then extracts the dominant sort of motion vector in it, and then constructs a histogram of those. And then it becomes a sort of small representation of the image upon which you can plug some image, or some shallow machine learning model to it, right? And this is basically how machine learning worked for a really long time. And the problem with this is that well, first of all, it worked pretty well, right? Like we could do like basic computer vision for a long time. And it was pretty interpretable, and it was simple enough to implement on commodity, like even on the laptop, you could do this, 10 years ago, right? However, it didn't work that well, not so well that, to inspire the kind of excitement that we see around machine learning today. And it was also like not very general, right? And because, for example, these features that we're looking at are really only relevant to computer vision. And they're not relevant to audio or to text. They're not even relevant to other tasks within computer vision, right? So if you wanted to teach this AI, let's call it, to do something totally different, you'd have to start over. So it's not very general. And generality is an important component of AI, right? We want to create AIs that can respond, that can be deployed in a very, very wide variety of situations, right? So now what's happened now is that we've replaced all of this with very, very deep learning algorithms, right? And this is kind of what we mean by deep learning. Generally, it means like neural networks with many layers that do multiple rounds of processing, taking raw input data, like an image, it's pixels or it's audio samples or text or whatever, and learning an efficient representation that is good enough to do some sort of image, some sort of a task at the end of this. It's trained end to end, has very good performance. The code is very homogeneous, so it's kind of easy to work with, and it generalizes very well. So you can use the same approach for completely different tasks usually. All you have to really define is your objective, and then the machine learning takes care of the rest. So it's much more general, and it's been much more successful at a lot of tasks that are important to people, and that has inspired a great deal of like incredible applications that we've seen. So this is just like a small selection of really, really sort of recent applications that we've become quite good at, right? So speech recognition is done by deep neural networks, and so is computer vision. So self-driving cars are all using what are called convolutional neural networks. We're not going to talk about how those work so much, but that's kind of the workhorse of most of this. And also things as different from these two as machines that play Go or play other kinds of games or interact with an environment, right? This is like just some more applications. As you can see, there's quite a bit of diversity in the applications of deep learning. So extracting roads inside of satellite imagery, identifying galaxies, generating speech. So that's kind of like what we're looking at as wave nets. There's also been a huge explosion in medical diagnostic applications. So this is from a paper that shows how to detect breast cancer inside of basically in histology images. And generally speaking, like a lot of this kind of stuff is now done better by neural networks than it's done by even doctors, right? So we're seeing like a huge explosion of these kinds of applications. There's captioning systems, right? So like things that can take images and describe them in natural language, and lots of others. And then my personal favorite is, of course, like artistic applications. And I mentioned this like really quickly. We're not going to talk about this today, but this is kind of what I do most of the time. So generating images and sounds and text that's kind of more creative or maybe like less useful, I guess, than some of the other things that we looked at. And for this reason, because of all of these disparate applications, there's been a huge increase in interest in this field, a lot of investment, a lot of hype, of course, a lot of press. A lot of people are calling this like the new golden age of AI, where the first one was in the 1950s and 60s when humans first became excited about this idea that we could create AI. If you ever like saw science fiction stuff from the 1960s, you know that it was very sort of like AI utopia, and so forth. And of course, the investment numbers have been really staggering. So just 5 or 10 years ago, major tech companies might have maybe like 1 or 2 people on their payroll who had some experience with machine learning. Now they have entire departments, right, that are doing this kind of stuff. And you get quotations like this from the CEO of Google, Sundar Pichai, who says, "Machine learning is a core transformative way by which we're rethinking everything we're doing." Right. So this is the largest well, maybe not the largest, but like basically the most important company on earth, saying machine learning is everything that we do now. And if you look at their products, it basically is. So this is kind of the way things have changed over the last few years. I've been really also like excited about developments in how machine learning is done. It's a lot more open than it used to be. So like when I first became interested in it, the only way that you could really like learn about machine learning was by either being a graduate student or by buying expensive textbooks and basically learning it on your own. Now there's like actually quite a big online community that is not really concerned with credentials or university degrees or things like that. There's a lot of people discussing this stuff online. There's all the paper publishing is completely open access. So archive.org is basically at this point in deep learning like universally selected as a publishing source. People publish in advance of conferences and journals and things like that. They share their research early and often. They talk about it online on like the Reddit machine learning channel, on Twitter. You have things like Kaggle, where like amateur data scientists can compete and try to earn money actually independently doing machine learning tasks. You don't have to be hired by anyone. You can just submit algorithms, right, to try to win competitions. So a lot of this stuff is like is I think actually like a really good development. And of course, a lot of this has also been supported by the appearance of these open source frameworks for doing machine learning. So you might be familiar with like TensorFlow and Torch, and this one Theano is actually being discontinued now because of the appearance of Theano and Torch, because of TensorFlow and Torch. But of course, like this is completely different because before, like all the machine learning stuff would be in like MATLAB or something like that, which you would have to buy a very expensive license for, or have your university or your work do it for you. And so this is kind of like much more open, much easier to enter. It's not an easy topic to learn about, but it's much more accessible than it used to be. So that's kind of a nice development. So let's talk about how machine learning is done and start to connect it back to this notion of decentralization, why it's kind of important. So what I'm about to describe to you is the basic machine learning pipeline that describes pretty much 99% of machine learning today. You have some company, let's call them AI Incorporated, which wants to train a machine learning model to do some task, right? So it will create some model, instantiate it, like a neural network or whatever, and it will have users submit data to it. It will take their data. It will then train the neural network on it. Now these are green because it's trained. And then it will give them back some service, so YouTube recommendations or something like that. And then the AI Incorporated will sell the data, and that's how the business works, right? And this completely describes pretty much every technology company, the way it works. They're all pretty much, taking your data, training, doing some data science in it so they can learn very interesting things, and then either selling the data or selling the service as an API or something like that. And this describes, the way Facebook's business model, Google's business model, and pretty much every major tech company. So let's talk about like some problems with this, right? One problem is that there's a constant tension between the users and the company with respect to things like privacy, right? So you have this data. The data is very personal sometimes, and so of course there's a tension to giving it up to a company, and then of course it's there's a convenience to they want to create some convenience in your life, so like giving you news that's most relevant to you, right? And of course the trade-off is that you have to give them data about yourself, and this is irreconcilable. This is always a tension, always a problem somehow. The second problem is that this notion of lost natural income. So when you are generating data for AI Incorporated, it's a labor that you're performing, right? You are generating data, and you're doing it through the way that you're interacting with our service, and you are not being paid for it or compensated in any way, right? And of course, like the return is that you get some free service, which is usually not a very good service, right? And many people, and this is not just about machine learning, just in general. Many people have been commenting on this for years that this is kind of like the economic model behind this is a little backwards. Like maybe it should make sense that when people generate data, there should be some incentive for them to do so, rather than just getting some free service from it. The third problem is that the data is aggregated into just a few very large data silos, right? So Facebook, Google, I believe those two companies together accounted for something like 77, I think I read this today, 77% of all advertising income online in 2017. And advertising is the product that's connected to having data. That's the business model of the internet. So these two companies soak up all of the data, and a small number of people have ultimate control over that data. Where it goes, what it's used for, who has access to it, and all sorts of other things, right? So this is kind of like creates this big power dynamic where several companies have the most precious resource of the 21st century, which is data about people, right? And people call data the new oil, right? So, and there's a lot of truth to that, I think. And this one is kind of related to the first one, the fourth, the privacy issue. Some products that companies would like to provide are very sensitive, right? So you can imagine that some companies out there would like to do, for example, to monitor your health and maybe warn you of some potential problem with your health, right? But of course, there's a disincentive to share that about yourself because you're afraid it might be used against you, which it often is, right? So that's just a fact. And so again, you can see that this creates a very inefficient and possibly like suboptimal model of interaction between customers and AI companies, right? So enter decentralization technology. So I'm going to now shift gears and talk about decentralization stuff, and then we'll kind of loop back to how these decentralization products can maybe either solve or at least improve some of the problems that we observe with machine learning. And I want to first start by kind of giving you like a sort of taxonomy of decentralization technology, because it's not just about Bitcoin and it's not just about blockchain, right? Decentralization it can refer, at least like, I'm talking about mostly contemporary things. I imagine kind of there's like three categories of things. Decentralization is the outer bubble here, where we're trying to decentralize all of the things that possibly that you do online. For example, storage of data, computation itself, sort of network topology, things like that. And there's all of these different either companies or open source initiatives, many of which are decentralized themselves, not all of them are, which are attempting to actually try to create these services in a decentralized manner, which is to say that the service exists independent of some central authority. And this is just a few of them, and I'll actually talk about a few of these in more detail later. But IPDB and IPFS, for example, I'll talk about later. These are all examples of decentralization technologies, which aren't necessarily just blockchain stuff, right? So blockchain takes up most of the attention in the decentralization space, but it's really only half the story. Then you go to the middle layer, and then we have blockchain stuff, right? So and what most people associate with blockchain is Bitcoin, which was the first blockchain. But blockchains can be used for all sorts of other kinds of value exchanges, right? So or keeping track of some evolving system, right? So if you think about like business logic, if you want to decentralize business logic, you need to have some like decentralized computer that is actually computing the logical steps. And how do you do that in a decentralized way? Maybe on some computation that's distributed somehow. Again, we'll talk about these in more detail. And then at the lowest level here, we have cryptocurrencies, right? And that's kind of the most specific. And that's your Bitcoins and your Moneros and your Zcash and all this kind of other stuff. And yeah, we'll kind of get into those. So just to dispel like a few maybe like cliches that I like to kind of start with. So if you ever like have Googled decentralization, you'll find that like half of every blog post or chapter that's written has this famous graphic that shows centralized, decentralized, and distributed systems. And I think sometimes this is like doesn't capture the whole story because decentralization exists on many axes. So any service can be decentralized in some ways and not decentralized in other ways, right? So, for example, like if you consider Bitcoin, which is commonly called decentralized, well, that's only half the story because it's decentralized in the operation of the network, but of course there is a developer community, there's a core developer community that's involved in developing it. There's a Bitcoin Foundation, which is it's not official exactly because there's no notion of official in a decentralized entity, but it's de facto one organization that's developing it. So there is some centralization to Bitcoin. Of course, like there's also the mining pools that have emerged that have a huge amount of political power. And so decentralization is not like a binary thing. It's not either that you have a central authority or nothing. It's kind of this axis. And something can be decentralized, in terms of operation, but maybe it's or it could, let's say, be decentralized in its operation, but decentralized or fully centralized in some political, like a political or authoritative structure. And decentralization is not just about Bitcoin, and of course, like Bitcoin is like skyrocketing in price right now, so of course all of the news is about it. And Bitcoin has this kind of quasi-libertarian culture to it. But there's a lot more to decentralization than just Bitcoin. There's a lot more than just blockchains. I'm going to talk about things like IPFS later, which don't have anything to do with blockchains, but are actually quite interesting in their own regard. And actually yesterday I talked about it at much more length at CIS. We talked about decentralized web technology. And these things are actually really important to be aware of. And what you find as you get into this ecosystem is that a lot of these new services are actually like very complementary to each other, and that if you're building some sort of what you hope to be a decentralized service, you might be using multiple systems at once to handle various aspects of the product that you're creating. And finally, decentralization is not new. Does anyone recognize this graphic on the left? This is the original schematic that described ARPANET, which was the internet, the very beginning of the internet in the late 1970s. At the time, we had figured out how to have computers communicate with each other using telecommunications infrastructure. And along came a few people who said, wouldn't it be great if all of these different networks, which had developed proprietary technologies to communicate amongst each other, wouldn't it be great if they could communicate with each other? Because all of them were using different protocols that they had invented. Like IBM had one thing, and maybe the U.S. Navy had another thing. And so along came a number of people and developed a whole bunch of the protocols that now govern all of internet telecommunications today, right? So I'm sure everyone's here is familiar with HTTP and FTP and DNS and TCP and IP and all these protocols, which define very precisely how to implement something that can interact with the internet. And then they set about convincing everybody to adopt it, and then the internet was born. So when this happened, the original idea was the internet was going to create decentralized telecommunications among people, right? So suddenly all these computers can interact with each other. You have a computer at home, or maybe you have a computer at your workplace, and you can all talk to each other, right? And the original spirit of the internet was very much decentralized, right? This idea that we could, communicate in a decentralized manner. But what happened? What happened is that all of these things happened. So some of the components, some of the nodes in this decentralized graph grew to be very, very large because they provided some superior service. And over time, a lot of the traffic began to concentrate in very, very small portions of this graph of people communicating with each other. So of course, like everyone recognizes all of these, you know, Twitter, and your Google, and your Facebook, and so on, Yahoo. And I also like to point out that so the following companies: eBay, PayPal, Amazon, Airbnb, and Uber, and I think a few others that you can mention. They were all like the whole idea of them was a sort of like to be decentralized, right? So like eBay was like, oh, finally a buyer can sell, so someone can sell go straight from buyer to seller without some middleman, you know, in the middle. But what happened over time is that eBay grew, and then they had to get involved in settling disputes, and they just became another middleman, right? And this is the same as true of Amazon, and then sharing economy apps, or what they call themselves, sharing economy apps, but, you know, like Airbnb and Uber, same thing, right? That was kind of like their selling point, but really they just grew to become, you know, a big sort of middleman. And so decentralization was effectively centralized, and this was very largely consolidated over the last 10 years, I'd say 10 to 15 years. Even in the 1990s, things were still like, you know, a little bit more diffuse. Things now have become very centralized. So this is manifested in some problems with the web today, and I'm going to talk later about IPFS, which is kind of like the initiative that's trying to solve these problems in particular. But I'm going to first introduce these problems. Right? So what's wrong with the web today? It's slow and inefficient, right? And this is sort of contrary to people's perception. You know, the internet has gotten faster over time, but it's beginning to plateau in this regard. And you can see that I don't have these graphs, but if you look up over the last 10 years or so, you've seen that the price of storage has plummeted. You know, it's become extremely cheap to store things on computers, to back things up in the cloud and things like that. That's the price of that has plummeted, but the price of bandwidth has kind of stagnated. It's not getting cheaper as fast as storage, which is to say that we're accumulating more and more and more content, but not getting faster at traversing this content, which gives us the perception that the web is actually getting slower. And this is particularly true, like I think here, especially in India, where everyone is basically connected to the internet, but you can go in many places where it's extremely slow. And this is actually a big barrier to using a lot of services online. That's kind of one problem. Another problem is that the web is not really secure. It wasn't built to be secure. It was built sort of before the notion of cybersecurity was really like the kind of issue that it is today. So if you know, the way that security is added is, well, first of all, why is it insecure, right? Because when you're interacting with services online, you have to trust them, right? So if you're requesting some content from a service provider, you have to trust that they're not being malicious or giving you some computer virus or its modern day form, which is advertising. This is what used to be called computer viruses. But anyway, and you know, the way that we kind of made this more secure is through what's called security through through insecure channels. What is it? Security on insecure channels. Secure communications through insecure channels. So encrypting content while it goes through those pipes and gets to you, and doing all sorts of complicated cryptography, like to secure these insecure channels. And this, you know, works pretty well, but it can break down. And of course, it breaks down because it's kind of a patch to the infrastructure of the internet. The infrastructure of the internet is insecure by default. We have to secure it with all of these appendages and all these patches. The other thing is it's unreliable and impermanent. So how many people here remember GeoCities? So geocities.com/Hollywood/lot/6641. That was my first website. And you can no longer find it online because a couple of years ago, Yahoo bought GeoCities and then decided that we're just going to shut it down. And then this huge trove of early web content was completely lost forever. And of course, this happens all the time. How often do you get a 404 page when you try to click on a link for some, resource that you're looking for? It's often gone because, some webmaster took it down, or maybe the ISP that is hosting it decided to take it offline. It's impermanent, which means that we're losing a lot of valuable, often very valuable, content about ourselves. And there's things like archive.org, right? Not the same one I mentioned before with an X, but with a CH, archive.org, which tries to kind of tries to just save a version of the web every day. But there's only so far that this can get us, right? So this is another problem. And then this I already made reference to, this notion of accumulated data. So this picture is of some random server farm owned by Facebook. You can tell it's Facebook because of the blue glow. And it has, thousands of servers. This is some random location that's possibly a secret. Actually, I don't even know where it is, like in Utah or something. And it holds, all of our data. And a very small, very select group of people on the inside of Facebook have ultimate power over that data. So when you interact with Facebook and you post something there, you are signing off your rights to that post. You came up with it, it's your content, but then Facebook has end game usage rights over it, right? So it can censor it if it doesn't like it, or it's been asked to, or maybe it decides that the service that you put it on is no longer relevant to their business model, so they just take it off. And then you can't use that same content for another page, right? So there's some, maybe okay, Facebook lets you cross-post to Twitter and vice versa, but they're always quite reluctant to do this. And you'll see that there's a lot of friction for using your data for multiple services, right? So this is kind of because it's a competitive advantage, right? Data is the new oil, right, as we said. So it's in Facebook's best interest to keep that data for themselves and not let others use it or build products off of it. So these are all problems with the web, right? Now there's been the emergence of peer-to-peer networks over the last 10 to 15 years, which have tried to create some alternatives to this. So a peer-to-peer network is, it's a decentralized computer network, right? So this is the centralized model, the server-based model, where you have some central server that deploys content to a bunch of clients. This is what we call a server-client model, right? And all of the dominant protocols that the web works on, from HTTP on down, and IP and so on, they all start with assuming a server-client model, where you are requesting some content from a server, and it is sending it to you. You are the client. Right? In a peer-to-peer network, you get rid of the central server, and you just have communications among all the nodes, right? And we've seen, way before blockchain, there's been a lot of peer-to-peer networks that are quite decentralized, right? So this is just a few of them. The top left here is a screenshot from Napster. Who remembers Napster? This was, of course, a way to discover lots of music. Back in the day, and then Napster was kind of succeeded to some degree in terms of peer-to-peer file sharing by BitTorrent, right, which is kind of it's a decentralized peer-to-peer network of people exchanging files. And then these are kind of a few more recent ones. This one, this one here on the right is called Diaspora. How many people here have heard of Diaspora? A few people, right? So Diaspora is essentially a decentralized Facebook. And it was this really, really, well-intended initiative that was started, I'm not sure how long ago now, maybe someone knows better than me, I think, maybe as far back as 10 years ago, in the aftermath of Facebook. But it never really scaled very well. So today, I think Diaspora has something like 1 million users, which is, like respectable. But Facebook has 1 billion users, right? So it's quite a big difference in magnitude, and so it never really quite took off, right? And then you have, this is much more recent. This is called Mastodon. So Mastodon is a sort of quasi-decentralized, probably more accurate to call it federated, a federated version of Twitter. So it's an open source software which re-implements basically what Twitter has, and then anyone can start a Mastodon, server, which participates in this network, this federated network of like mutually interoperable Mastodon servers, which each have their own like rules. They can all like fork the software and adapt it and make their own sort of custom rules and things like that. And so this is kind of an initiative that's more recent, that's trying to basically make like, again, like quasi-decentralized Twitter. It's like, I say quasi-decentralized because I think like one Mastodon server accounts for like 50% of the accounts. So it's like not exactly, like as we said, decentralization is a continuum. And so it's not really fully peer-to-peer exactly, but it is like a step in that direction at least. And then this one at the bottom is specific to Germany, which is where I live right now, Freifunk, which means free radio. So this is a huge initiative that's quite popular in Germany to create a decentralized wireless internet network, right? So like a bunch of peer-to-peer nodes that share internet connection, and it's a pretty active initiative in Germany. So let's talk about cryptography, and this is going to be, so the next section is I want to talk about like how we are going to decentralize some of these things, and then once we have this sort of idea of like how things are decentralized, we'll turn back to AI and start to make things. I want to keep everything sort of so you know where I'm going with everything. But I want to do like a very quick review of cryptography, which I'm not going to talk about in any technical detail. On Sunday, when we have our workshop, which actually raise your hand if you're going to be at the workshop on Sunday. Just just a few of you. Okay, so most people won't be. So that's fine. I'm just, for those of you who are going to be there, all of these, like I'm going to talk about these in more technical detail, like how some of these protocols work. But for now, I'm just going to talk about applications, just to keep things like at a high level. So the basis for most decentralization technology now, some of this newer stuff is cryptography. And cryptography is the science of obfuscating communications. How many people here are like familiar with cryptography to some degree? Like, a lot of people, right? So not surprised. So you're all probably quite familiar with a lot, we don't have to spend too much time on them. These are just some of the applications of cryptography. So for example, top left here is PGP mail. So PGP is a system of encrypted communications, generally used for email. Stands for pretty good privacy, which is kind of an understatement. And it uses public and private key cryptography to secure communications. So in public and private key cryptography, any entity, like a person, generates one public and one private key, and you can use the public key to encrypt communications to that person, and then only the private key can be used to decrypt them. Right? So if you're the person who is being communicated with, you have a private key, and only you know what it is, and so therefore only you can open encrypted communications to you that was encrypted with the public key corresponding to the private key that you have. So, and this is of course used not just in email, but it's also used in like, apps like Signal and Telegram, and even WhatsApp uses it. So they use encryption to make it so that you have some amount of privacy through their service. They don't, especially Signal and Telegram, they don't store your unencrypted communications anywhere. So this gives you some level of privacy. Cryptography is also used to do as I called it, secure communications through insecure channels. So things like TLS and SSL. If you've ever used HTTPS, this is secure internet browsing, right? and that's another application. And then these are related, so VPN is a way of browsing the internet securely through an intermediary, encrypting your traffic, encrypting your requests. And then finally Tor, right? Tor is the onion network, so this is kind of like a way of browsing the internet securely through a peer-to-peer network of volunteer nodes that encrypt your traffic in multiple layers of encryption in such a way that no node in the network has all of the information necessary to know who is visiting what. Right? So this is kind of a way of obfuscating web browsing. So these are all efforts to kind of make the web more secure, more private, and they've been like quite successful, of course, for a long time, and precede a lot of the excitement that we see with blockchains. And blockchains kind of take this stuff to the next level that we'll get into. So getting into blockchains, the very first blockchain was Bitcoin, right? So of course everyone knows Bitcoin. You can't walk anywhere, turn a corner without hearing about it. Quite sick of it by now. But Bitcoin, of course, but Bitcoin is really impressive, right? It was really the first time we ever saw something like this work at a mass scale that involves money, right? Involves value transfer, a peer-to-peer network that has money built into it, and really that never existed before Bitcoin, or at least it didn't exist in a decentralized manner like Bitcoin. And Bitcoin was has been around now for about 7 years. And what it is, of course, is it's a peer-to-peer, currency, right? So you can exchange money directly between nodes in the peer. There's no central authority that issues the money. There's no central authority that governs it. Well, as we said, there's developers, there's miners, and they all have their say. But the functioning of the network on a day-to-day level does not depend on any central authority to actually authenticate transfers of money, right? The way that we usually rely on banks to do so. And Bitcoin is secured using a very elaborate and very sort of like wasteful system of cryptography to basically make nodes expend an arbitrarily large amount of computation to authenticate transactions. And this is a way that, again, I'll talk about this on Sunday and much more we'll actually talk about the Bitcoin protocol, each step of it. But at a high level, you're using, you're making people solve very, very arbitrary and meaningless computational puzzles in order to authenticate transactions. And this is a way of reaching consensus on the order of transactions and therefore how much money everyone has in a completely decentralized way. And that's kind of like what Bitcoin is. And this is the only investment advice I'll give you. Don't invest in Bitcoin. It wastes so much energy. Like this, these are just some graphs I found the other day. Bitcoin network now uses as much electricity as Denmark, as the whole country of Denmark, and it's projected that sometime in 2018 it will overtake the United States as the biggest expenditure of electricity in the world. And the higher its price goes up, the more people make from mining, and then that just drives up the energy usage even more. So it's this kind of like runaway, out of control, train. As I said, there's lots of amazing things about Bitcoin, but of course it's also the case that there's this huge ecosystem now of really interesting projects, including other cryptocurrencies, that many of which are actually trying to solve this energy waste problem and inefficiency problem. And maybe the silver lining is that if Bitcoin keeps on rising, at some point the money will kind of drip down into these other ventures. I don't know if that will happen, but that's kind of like the state of things today. So getting back to the decentralized web. So as I said, it's not all just blockchains, right? So this is a really cool initiative called IPFS, which stands for Interplanetary File System, which is a open source initiative to try to re-decentralize the World Wide Web and basically reinvent the protocols that the World Wide Web works with from the ground up. So starting with HTTP and IP and all these protocols to basically just get rid of them and start from scratch. And do so by creating a decentralized graph. And again, like this, I'm going to talk about it in more detail on Sunday when we have the workshop. But at a high level, what IPFS is it's trying to replace the server-client model of the World Wide Web, where you have some, a few very big central servers that are providing these services. Replace it with a completely decentralized peer-to-peer network of nodes that are, trading content with each other. And it uses a lot of really quite recent innovations that have come out of academia in general for efficiently hosting content and kind of trading content. In some ways, I like to think of it like a few people have made this analogy, including Juan Benet, who kind of started IPFS, that IPFS is kind of like Git for the internet. So how many people here are developers and know of GitHub? So imagine if the whole internet were like GitHub. All of the content were, there was version control for all of the content, right? So as you go through versions of the web, all of the previous versions are saved, right? You have this kind of like trail of commits, and so nothing ever goes away. You can always recover something. Now, of course, that creates certain kinds of risks, right? Like, what if there's content on the web that you don't want to be there? Right? Like, some content does need to go away sometimes. And the answer to that is that you also get rid of these data silos and you make the data layer something that's controlled by the user ultimately. So if you're a content creator and you put up some content, ultimately you can make the content such that no one can access it, right? Or you can revoke the service's ability to use it. Basically like putting the content creators of data in charge of their own data, making data a sort of public utility. And so this is kind of the IPFS venture. And then also websites and services don't have any central origin. They don't have a point of failure. And security is built into the protocol in like really clever ways. We'll talk about on Sunday we'll talk about this notion of location or content addressing and so on. So I want to, let's actually we'll just take a break right now, and that's kind of we'll kind of continue this after a short break and talk about some more. Okay, so getting back. So I just mentioned IPFS, right? IPFS kind of takes care of one element of this, which is the creation of a data structure for the web that kind of is able to efficiently find nodes to distribute content. But that doesn't solve everything for a decentralized web. There also has to be some way of storing the data, and especially large data. And so this kind of ties into, there's now been a few initiatives that have started up that are interested in creating a decentralized file storage mechanism. So like right now, the way file storage generally works is you have servers, right? You have small servers that might host your content. And a lot of it is now shifting to really large systems, like, for example, Google Cloud and Azure and Amazon S3 and things like that. So there are a number of initiatives that say, wouldn't it be nice if maybe we can create a decentralized market for file storage? So you have some excess hard drive space in your computer, maybe you can make it available for other people to host their content on it, and maybe you can get paid for it too, right? So people should be paid for this as a service. So you create a market, some people buy, some people sell, and in general, because there's no middleman to kind of take a cut, it should be much more, much cheaper, much more equitable, and so on, and much more efficient because it makes use of all this sort of excess hard drive space that we have. And Filecoin is actually I think the sister project to IPFS. It's meant to be very complementary. Storage is another one that's in this space. And of course there's lots of there's a lot of outstanding questions to how this would work effectively. How do you ensure that people are actually storing the data? How do you trust them? To keep your data, of course, encryption works its way into here, so you don't actually give people the raw data, but the encrypted version of it. And there's some fault tolerance built into the systems by hosting the content in multiple places at one time, so to prevent, if one of the nodes fails, then your content can still be recovered. All of those are like questions that are being worked on right now. And a few people have asked me during the break, how can I sort of get involved in some of these projects? And basically all the ones that I'm listing right now are all effectively open source projects. So you can find them online. A lot of them have like a Slack channel or a Gitter channel, of course, basically all of them are open source projects on GitHub. They're all looking for contributors. They have documentation. They're sort of like new projects. So they're all really hungry for people to contribute. And this is just like a sampling of a few other services that are really, really small sampling. Like this is not by any means like even my favorite ones. This is just like a few that are trying to provide some like a decentralized version of something which is done by a tech company right now, right? So like for example, Steemit is this company that's trying to create something akin to like a Reddit, which tries to incentivize people to post content by giving them tokens whenever they get upvotes in the content, right? So we haven't talked about tokens, but this is a whole other aspect to the sort of blockchain space. You can create tokens which are a store of value, which can be used in some closed sort of loop, right, in sort of ecosystem. You have things like OpenBazaar, which is kind of like the truly decentralized version of Amazon. This is a really cool one that's actually mostly in Berlin, or at least started in Berlin, which is kind of like a decentralized version of SoundCloud, so for musicians to host and stream content and kind of share music and things like that. Then you have IOTA, which is trying to tokenize Internet of Things devices, and just lots of things in this ecosystem, right? And actually, like, I have a graphic here that just shows like just how many hundreds of these things there are. This is just, again, like a sampling. I think these are just some companies that were present at the last Ethereum conference. I'll mention Ethereum in a second. And then this one is actually quite interesting also. There's two companies, probably 3 or 4, besides for these, Golem and Truebit, which are working on decentralized computation. So kind of equivalent to Filecoin and storage for storage, except for computation. So instead of excess hard disk space, excess CPU power or GPU power. You have some sort of a computation you have to do, maybe a scientific computation, like machine learning, protein folding, gene sequencing, things like that. You can have it done on excess computation that all of us have on our devices. And again, you can create a marketplace for it. You can create a token which incentivizes people to participate in it. And that provides another element of decentralized computational services, right? Because if you're creating a service, there's multiple things you have to take care of at once, right? There's the computation, there's the storage, there's some sort of like if you're working with databases, there has to be some way of querying databases. All of these things either rely on a centralized service or they rely on maybe a peer-to-peer graph, right? So these are all trying to provide each of those components. And then this is really new, and this is done by actually some friends of mine in Berlin. There's a new thing called Ocean Protocol, which is trying to create basically a decentralized data marketplace. Right? So I mentioned before that we have this big problem of data being siloed into companies, right? Well, what if instead you had the way that we organize data was into one large kind of collective, what we might think of as a global data commons, right? And services, your Facebooks and your Googles and your Reddits and so on, rather than holding the data themselves and accumulating it, they are simply a service layer on top of this resource that they share, right, with each other. And anyone who puts data into this big decentralized data global data commons has usage rights over it, so they can license it. They can provide all of the rules of how it can be used. They can revoke access. Ultimately, the person who puts the data onto it has final say of how it's used, rather than the service provider, the company. And then, of course, there's like just lots and lots of different use cases for this. The people that are making this talk about how, for example, companies can share data in situations where they otherwise would not have. So, for example, like you have self-driving car companies, which have to train, they have to train AIs to drive cars, and for that you need a lot of data, right? And it's really expensive to acquire that data, especially for something like self-driving cars, where if it makes a mistake, of course, there's a lot of destruction, right? So it would be great if you're able to kind of get a head start by sharing data. But the thing is that these companies that have this, data is their bread and butter. It's the thing that gives their company value. So what is the incentive for them to share it? Well, if you create a sort of marketplace for them where they can exchange data, maybe pool it together, and license it to each other, then you can maybe provide the right sort of balance of incentives to actually collaborate. And this makes it a lot. This will really, really improve. First of all, it'll improve the state of AI, because for two reasons. One is that now there will be a way of sort of greasing these gears, right, to allow data to be accumulated where it's needed from multiple sources. And also, it's also useful because most of the data is not actually, you have to be inside of one of these companies in order to do a machine learning experiment on it, right? And this will maybe create a mechanism by which it's not just simply who's inside and who's outside these companies, but rather anyone can participate if they have the right objective in mind, or an objective that's useful to other people. So this is kind of another really interesting objective. I want to talk really quickly about smart contracts in Ethereum. So all of this stuff depends a little bit on being able to have rules and logic that is carried out and agreed upon. And now this is easy to do when you have a centralized service. You have one computer that's kind of handling all the logic. But what if you want to be able to do this thing in a decentralized way? So for that, you need to have some way of doing more advanced computation. Now, so for something like Bitcoin, of course, it's really simple. It's just people exchanging money. Right? But if you have an application which is somewhat more complicated, you'll have to write you have to do something a little bit more more complex. And smart contracts are a way of enabling a class of applications that are much more general than simply exchanging tokens with each other. Right? And this is kind of a concept that's been around since the 1990s. Nick Szabo first wrote about it. And the idea of a smart contract is it's a contract which is digital, it's programmed, and it's effectively self-enforcing. So if you can create a contract which is computed over without necessarily needing some after the fact permission from the parties, then you can create a system by which logic can be executed in a way that everyone can agree is secure and will work and transparent and all of these things. Nick Szabo made this analogy of a smart contract to a vending machine. So a vending machine is like the physical manifestation of a smart contract, which is an analogy I really, really like. So you can imagine a vending machine. It's just like a program that has a few rules in it. Put in $2 and get back a candy bar. Put in $2 and request a candy bar that I don't have, and you get your $2 back. Right? You have this sort of very simple logic programmed into it, and it would cost you more money to break into it than is worth, because of course, the vending machine is really hard to break into, and you wouldn't break into it just to steal some chips, right? So this is kind of like the idea behind Ethereum, right? Which kind of emerged in the wake of this phenomenon that we started to observe a few years ago, that a lot of people began to consider like second generation applications on top of Bitcoin, or more complex ways of interaction besides for just exchanging money. As people began to think about developing these, Ethereum kind of emerged as that promised to become a platform where you can deploy smart contracts that carry out much more complex logic. Right? So, for example, things like like a vending machine except online, you might say. And again, like I don't have time to get into the Ethereum protocol. We'll talk about that on Sunday. But basically, it's de facto leader for deploying smart contracts on a decentralized blockchain. And as we talked about, smart contracts are sort of the basis for all of the stuff that Ethereum does. And with smart contracts, you can create what are called decentralized applications, and I'll get into decentralized autonomous organizations. So as I get into these slides, I just want to mention that like we're starting to get into like keep an eye out on the things that we're going to talk about, because we're starting to get into things of more complex, that are more complex in their construction, and things that have some sort of like complex behavior built in. So this is where the AI element begins to become relevant, and I'm gonna introduce the AI stuff after we mention DAOs. So decentralized applications can be defined very roughly as kind of like this, right? You have a sort of entity which has maybe one or more smart contracts in it, which contains some logic for operating an organization or some behavior, and maybe it can store money as well. So like a simple thing. Now, decentralized applications have existed for a long time. Like as I mentioned, BitTorrent is a decentralized application. It doesn't store money, right? But it has logic, programming built into it, and it has people at the outside, right? So decentralized application is something that it operates autonomously, is independent of every individual person that is interacting with it, but it's effectively is a way for people to interact through it. And in the blockchain world, this often carries some association with cryptocurrency, right? So cryptocurrency is used to transmit value, and this is really the difference between second-generation decentralized applications and first-generation ones, like the peer-to-peer networks I mentioned, like BitTorrent. None of them have a way of exchanging money, right? Like you don't exchange money in BitTorrent, which is good because before blockchains, there would be really no way of doing this securely. Not any way of doing it without some sort of a central intermediary, which would defeat the whole purpose of a decentralized file sharing system to begin with, right? So now the big difference is that now we can actually decentralize applications that carry value inside of them, like monetary value, economic value, and this dramatically increases the class of applications for which decentralization is relevant to. Now, then there's this kind of murky notion of a decentralized organization or a decentralized autonomous organization, and these two things kind of blend into each other a little bit. And I think like the best way of looking at it is a decentralized autonomous organization, or a DAO, a DAO, as we'll call it, to save breath. The difference between that and a decentralized application is that a DAO can also have some built-in capital or like built-in assets that it manages. So, for example, maybe deeds or usage rights to something, or maybe like assets like cars or houses. So, for example, suppose maybe you have like a car sharing service, right? And if you want it to be structured as a decentralized autonomous organization, you would have a smart contract which manages access rights to these cars. So a person, might want to rent a car, and so they deposit some money, into the DAO. There's a contract in there that says that if you give me money, I will program this car to open up when you come next to it. Right? And of course, the difference between this and a previous slide, just a decentralized application, is that the car is now entirely managed by the decentralized autonomous organization. And this is kind of a this really begins to get us into much more advanced territory. So like you can have cars that are managed by decentralized applications. And you know, when I say manage, right, when you hear the word manage, you think people, you know, like you think people managing things. But as I said, like there's no people in the middle here. There's no people managing those resources. There's no bosses, there's no, you know, middle managers, there's no employees, there's just a contract which manages access to a car. So that's a pretty interesting phenomenon, and one that is still very, very new. And there's not really a whole lot of things that have actually done this just yet, I suppose, because, well, again, like maybe it hasn't been quite enough time yet. But I think all the technology is there to create a completely decentralized car sharing service. Right? Another way of, you know, decentralized autonomous organizations can be increasingly complicated. So maybe they're not even just, like maybe you have multiple DAOs which interact with each other, right? Because basically all they have at the edges of each of these systems is a way to transmit messages. And the messages will trigger code to execute. And the code will execute and, you know, perform some action, like giving you access to a car or a house. But there's nothing to stop one DAO from transmitting messages to another DAO. Right? So one smart contract can send a message to another smart contract, and you can create like extremely complex and elaborate, you know, sequences or chains of communication between these different DAOs that all exist on the completely decentralized platform. Right? I know we're getting into like really abstract territory, and that's kind of like, it's hard to do anything about because again, we don't have a lot of like concrete examples of this. We just have like the tools emerging to build these kinds of services. So it kind of like, that's sort of the best that we can do right now. But I do have a few examples that I'll get into. I'm going to skip this slide actually, just in the interest of time. I want to give you a few concrete examples of DAOs that we could possibly encode as a smart contract that lives on the, you know, on a blockchain, like the Ethereum blockchain. So for example, how many people here are familiar with Kickstarter? Right? So Kickstarter would be a really, really easy DAO. Here's how it works. You have a smart contract that says, you know, someone can create a page and say, I want to raise money for this activity. And I need to raise this much money in this much time. And then you allow people to put money into the smart contract, and then the rules of the smart contract say that if you raise a certain minimum amount of money before a certain date, those funds will then be deployed to the creator, and if it does not meet the criteria, then the money is returned to the people who donated it. It's a really, really simple application, right? But it doesn't require a company in the middle that's there to manage it. Now, you know, you might be asking, like, is this useful or is it, you know, helpful? Like, what's wrong with Kickstarter? And that's kind of like, you know, not necessarily in the scope of this conversation. But you can imagine that if you have a system in which there is no central authority, then you have much less, you have fewer ways of, you know, controlling things or maybe censoring things. There's a lot of like, you know, things out there that are disfavored from these kinds of platforms. Now, you might agree with a lot of times, like with particular cases of something being dismissed from a platform, but you may also disagree sometimes, and that's kind of like, that becomes a really big and kind of existential question, like who decides these kinds of things, and that is the kind of question that people are beginning to ask. And you can also create, for example, co-ops that collaborate on insurance, let's say. You know, insurance can be something that can be encoded in a smart contract. If you know how it works in my home of the United States, my home country. It's basically like an embarrassing scandal right now. The health insurance scheme is basically like profits off of making people sick. I don't think that's an exaggeration. That's basically how things are in America. And I don't know if there's any like really good solution to this except to maybe just remove the insurance company from the business of insurance. Right? Maybe it's something that all of us can enter an agreement with a smart contract that says that if someone gets sick, there's some funds that get deployed. Now, there's all sorts of questions about that, like how do you prevent fraud, right? Like who's there to prevent fraud? Who decides how much money needs to be paid? All of those are outstanding questions. And there are ways of encoding human judgment into decentralized autonomous organizations. Doesn't mean no humans. It just means that humans are sort of at the edges. And so one concept that you see a lot in the blockchain space is this notion of oracles, which are like entities that carry some information that are sort of dissociated. It might be people, right, that are making decisions, but they're basically third parties. They are disinterested in the outcome of some transaction. And they can be, let's say, in an insurance situation, they can be empowered to be judges. It's not by any means a solved problem, right? But it's something that is increasingly more and more realistic as we sort of evaluate use cases. And I don't think any such thing exists yet, but it's reasonable to expect that it may in the future. And a few more experimental ones, and I'll be talking about, again, like I keep saying this, I'm a broken record, we'll talk about these in more detail on Sunday, but I'll just mention at a high level things like prediction markets and futurarchy, which are things that I myself know very little about. I just want to mention the one sentence I can tell you about them. And then, if it intrigues you, it's something worth looking up. It's something that I've kind of become familiar with recently. Futurarchy is this idea that you can basically fundamentally change the way that we do government. Now, the way you think of government right now, or governance in general, is in a democracy, let's say, is that people vote on policies or politicians, right? Representatives, or in the case of like a direct democracy, you vote on proposals and laws that will do something that you think is necessary, right? And this can be like really, really, well, of course, this is the best democracy that we have so far, I guess. But it has a lot of flaws, right? So one thing is that oftentimes people make mistakes in the sense that they believe a certain policy will have a certain outcome, and they turn out to be wrong, right? Because sometimes it's very complicated to evaluate policies, right? So in the futurarchy, the idea is, I want to say I'm not endorsing this necessarily because I don't know if it's good, if it works. There's been lots of debates online about this, but I think it's an interesting concept, worth sort of analyzing. In the futurarchy, instead of voting for policies, you vote for desired outcomes. So things that the society wants to achieve. So for example, and things that are measurable. So for example, it might be something as simple as, want this high of a GDP, right? Or maybe in a more specific case, maybe the society decides, okay, we want to reduce, we want to reduce infant mortality to below this percentage by this year. Right? Something that can be measured. And then you vote on the outcome. You vote that you want those things to happen rather than any specific policies that are designed to actually achieve those. So you vote for the policy, and then once the policies are you vote for the outcome, and once the outcomes are voted in, you create a prediction market, which is a market in which people can basically place bets on policies that will possibly achieve those outcomes. And the idea is that you are incentivizing people to put money, to stake money into policies that they think are going to actually achieve those things. And without getting into the details, which I don't fully understand, using first capitalism principles, that somehow the market will eventually converge onto solutions that are effective, like efficient, effective at achieving those things. Not sure if that's correct. Lots of good debates about that. But the idea is the idea is very much in line with a lot of the core ethos of decentralization. If you create the correct incentives, you will get like at least the best behaviors towards those desired outcomes that are available to you. And then, yeah, lots of other ones. Of course, there's lots of financial instruments like mutual funds and so on. I'm going to talk about Numeri in a couple of slides, which is another good example. So, of course, like if corporations are decentralized, then the perceived benefits that people talk about are that it's more transparent and it's more inclusive because it's kind of like fluid. Decentralized autonomous organization is effectively designed so that anyone can participate in it, or at least in principle, like it's able to interface with any person that bears an account in the system, and possibly resistant to collusion because all of the actions are public, they're transparent, and so on. And but that doesn't mean that all is well. Of course, there's dangers too. So what happens if it goes wrong? Right? Like, what if it does something wrong? Who's accountable for that? Right? And these questions are mirrored in the AI space. So people are asking, like, if a self-driving car makes an accident happen, who is accountable for that accident? Is it the person that developed the software? Is it the company that deployed the contract? Is it, who is it? It's really unclear. These are all emerging questions that there aren't any like very obvious answers to right now. And the questions are very much important to the decentralization space as well, because when you create decentralized autonomous organizations, by definition, they don't have people that are necessarily accountable to them. Right? So what happens when they do something wrong? That's maybe for us to figure out, right? And how they deal with externalities, like how do decentralized autonomous organizations deal with global warming, right? Like or climate change. Those are also, I think, very much unsettled questions. Okay, so now we're going to get into some like really heady territory, AI DAOs. So getting back to the AI concept. So what we've just described are, decentralized autonomous organizations are these entities which can perform very complex sequences of logic without any central authority to stop them or to start them. They interact with human beings, at the edges, but ultimately they are independent entities that have their own resources. Maybe they have their own cars, maybe they have their own houses. Now, what kinds of behaviors can we enable if we now add AI to the mix? And what do I mean by AI? Right? Like, I don't necessarily mean artificial general intelligence, which is still like a ways off, but maybe even like just like even relatively reasonably realistic AI. So just more complex, more sophisticated intelligent behavior. So like, for example, if you have a DAO which manages cars, right? Can you also make the car sort of do complicated things like look for clients, like maybe deploy advertisements, maybe manage its own money, comply with the law, and effectively own itself. Like maybe you can have a car sharing service which owns itself. So I'll make one example. So in Berlin, where I live, there is a company called Car2Go, which is a car sharing service, which there's no drivers. It's basically like it's like a car rental service, except there's no garages. It basically just cars parked on the street. You log into your phone and you go, I need a car. You find the nearest one that's been parked somewhere. You go and find it. It's programmed to open up only to your phone, so it has some NFC chip reader or something like that. Opens up, you drive it wherever you need to go, and you drop it off where it is, and then you leave it there for the next person who happens to be nearby that needs a car. Now, this is managed by a company, right now. It's called Car2Go. But in principle, there's no reason why this couldn't be programmed as a smart contract. Now, there's a lot of questions you might have, like, where does it get the cars, for example, right? So that's not clear. Like, maybe people donate it or something like that. But effectively, the whole system can be potentially managed by a decentralized autonomous organization. And you have, the capacity for increasingly elaborate, rules to govern it. And maybe like, for example, the cars have to do lots of things. Like, they have to figure out when does it need maintenance. Maybe it can subcontract. It can hire human clients to perform maintenance, to wash it, things like that. To donate the cars, like maybe it will buy the cars from people. Like, all this stuff is effectively, there's no reason why it can't be done. Well, I shouldn't say there's no reason why it can't be done without management, but it's increasingly realistic that you could do this without human management, right? So that's kind of like a thought that I'd like to put into your head. The idea that maybe something like Car2Go can be managed entirely by an AI, and have humans interacting with it on the surface, but essentially be autonomous, independent. There's another company that called Numerai, which is another, probably I think the most advanced example of both decentralization technology and AI. Numerai is not exactly a decentralized company. It actually is a company, but it's on its way possibly to becoming a decentralized company. What it is it's a hedge fund. It's a hedge fund which does what hedge funds do. It invests in companies, right? And it tries to buy stocks and things like that and so on. Except it has a really big difference from other hedge funds, which is that what it does is it makes all of its data public, and it allows any data scientist in the world to run machine learning experiments on their data and submit predictions to them for what stocks to buy and so on. And what it does is it takes all of those predictions and it combines them, and then it determines a policy of what stocks to buy and so on from all of these predictions being put into like a meta model that accumulates all these models and then combines them and then learns from them. And they encrypt all the data using what's called homomorphic encryption, which is something I'm going to talk about in the next slide, depending on how much time I have. And with homomorphic encryption, this is a type of technology. I'm going to describe it in more detail in a second, but it basically allows them to share their data with all these data scientists, except encrypt it. Encrypt it in such a way that none of these data scientists can take their data, of course, which is very valuable. But what they can do is actually perform machine learning experiments over the data, and then submit predictions back to them. So effectively, like, everyone is able to collaborate on one data set, and essentially it turns what used to be a zero-sum game of many hedge funds competing with each other for client money and so on, into one application in which in which all these data scientists can effectively collaborate together on financial policies, and it's pretty interesting, right? And I'll talk again like technical details on Sunday, but for now, like I'll mention one neat thing about this. I was actually just reading this yesterday, is that they have an ambition to not only to do what they're doing now, but to fully decentralize the company, so that it's not just it's no longer like one hedge fund, but it's rather like, well, it is still one hedge fund, but it's a hedge fund where there's not one entity which controls the data set. And if that were to happen, then I think at the most optimistic level, you could almost see this evolving. I don't know if it ever will become something like this, but at least, like, if we're being optimistic, it could evolve into making something like a hedge fund into or investment banking in general into a public utility, right? Like a communal property. And of course, finance is like really important now to society. Like it's the way that we determine how to allocate resources into things, into projects that will improve society, right? But the problem with finance right now is that it's completely centralized, and so a lot of companies are simply just greedy, right? Like this is kind of what caused the 2008 crash, is just a lot of like elaborate schemes to transfer wealth from one part of the population to the other, right? So ideally, of course, but it's impossible to get rid of finance, right? It's something that we have to do as a society. Well, what if finance were a public good? Right? Like, is that possible? Is that possible with a smart contract? Is it possible with decentralized autonomous organizations? And if it is, and if it's running AI, right? If it's running machine learning to actually determine what the optimal strategies are, then you have something that's like quite unprecedented, right? You have this like completely autonomous, intelligent algorithm which is determining how finance is done. I wish I could like speak more concretely about it, but it's one of these things that like is really hard to pin down because they're still sort of like very abstract concepts in their, and they're kind of percolating right now. But we'll see kind of like over the next few years how things like that develop. Okay, this is the last thing that I want to talk about, which is open mind. And I guess like, I don't know, I've been going really long, so like, is everyone okay with like another 10 minutes? This one, we should take about 10 minutes. So, so machine learning, which we introduced earlier today, we mentioned these, we posed these problems, right? There's a privacy convenience trade-off. There's always a tension between the client and the server. There's lost natural income, and there's data that's aggregated into silos, large power imbalances, and products are very sensitive, right? So mental health applications or physical health applications, like you can read lots and lots of things about how Facebook can infer extremely sensitive information about you just from who you associate with. And all of that is possible through machine learning, right? So these are all like things that create conflicts of interest when it comes to products that use machine learning. So is there a way that we can maybe fix this, right? And I'm going to describe to you one really, really new venture, which is called Open Mind. This is a really, really cool project that, again, like actually people have been asking me like what projects to participate in. If you're interested in all the things I'm talking about, like a lot of this is leading to this, because this is kind of a company that's attempting to combine all of these technologies to solve these problems. Whether they do so or not remains to be seen. It needs a lot of help, needs contributors, and it's just basically, it's not a company at all. It's just this open source project, and a community of people that are dedicated to solving it. It has a Slack channel and GitHub and so on. I'm going to describe the proposal that has been made by this community of people to create what they call encrypted decentralized artificial intelligence. Right? So the sort of nexus of all the things that we're talking about. So let's review. I mentioned this before. This is how centralized machine learning works. You have AI incorporated. You have a company. And by the way, I'm just summarizing. Like, if you go to OpenMind, like search for OpenMind on YouTube, you'll find a description that goes into much more detail than I'm about to, which will describe exactly how this works. I'm just kind of summarizing it. So in normal centralized machine learning, you have your company that has machine learning model. Users give their data to the company. Company takes the data, trains a machine learning model, gives services back to the users, and sells access to the model or the data itself to third parties for profit, right? And this has all of the problems that we just mentioned, right? So again, like, just to review, what are the problems with this? Data silos, we mentioned, power is aggregated, the data is aggregated into one company. There's the privacy tension, lost natural income. On the flip side, the model is secure, right? That's kind of a nice thing about it. The model never leaves AI incorporated, so they have access to it, right? So it's secure. Now, there's an emerging way of doing machine learning called federated learning. So if you've ever used, for example, like Google autocomplete, right? You actually have, in most cases, I think, for the most part, or like Google Translate also, you typically will have, or at least can have, the model downloaded to your phone, where you actually have a copy of the model and it processes on your phone. Rather than being like an API that you submit a request to, you actually do the machine learning on your phone or on your computer and so on, right? And what happens is that in federated learning, AI Incorporated will actually share the model. It'll send the model to the users. The users have the model locally, and they never give their data directly to AI Incorporated. And instead, they interact with the service, and they generate what are called gradients. Now, we haven't talked about what gradients are. In machine learning, when you have a neural network, or something like that, it is an algorithm which is characterized by a whole bunch of weights, or parameters, that define the behavior of the model. And the idea in training a neural network or training a machine learning model is that you have to find the correct weights that make it behave accurately, or or to sort of meet the objective that you require of it, right? And the way this is done in training is that you give it lots and lots of examples, you figure out what the correct answer should be and what you actually have, and you then calculate the difference that you have to make to all of the parameters in order to change the diff, right? And this is called the gradient. So the gradient is just a whole bunch of change all of these parameters by this much, and it'll make the model get slightly better. So in federated learning, the users have the model, and they simply send the gradients back to AI Incorporated. AI Incorporated then takes those gradients, and then combines them, and then trains the model, and then sends them a new version of the model, right? So, and then, gives them a service, and now it no longer has the user's data. So, actually the database should still be here, so a little bit of a bug. The users no longer have the data, but now AI Incorporated can still sell, the usage of that model, right? Because it's still a valuable resource, so it can still sell it. It doesn't have to sell the data anymore. So this is kind of a nice thing for many applications, but there's still some weaknesses, right? So the nice thing now is that the user never has to submit their data to the company, right? However, it turns out, for technical reasons we won't get into today, that the privacy is actually not preserved, or not directly anyway, because it turns out that in machine learning, the gradients can actually give hints about what's inside the data. And you can actually do a very good job reconstructing or inferring the original data entirely from the gradients, right? They give hints about the user's data. There's a whole field called differential privacy, which is dedicated to this problem, right? And it turns out that you can actually learn a lot about users from the gradients. And that's why if Google says oh, we're not actually saving your data, it's true, but slightly disingenuous, because it really turns out that they can still know everything. This is how Google's federated learning system works, and Apple's as well. They can still actually, if they wanted to, learn a lot about you. Now, the lost natural income is still a problem. Users are not getting paid for their submitting this data. And now we have a new problem, which is that the model can be stolen. So what AI Incorporated has just sent these neural networks to the users that they do the service. So what's to prevent the user from stealing it and making their own AI Incorporated, right? So this is a new problem. So the way that, so the next thing that we're going to introduce to this formula, and by the way, just as a warning, this is going to get increasingly complicated. So I'm just giving you the very high level view. As I said, you can find a more detailed view of this if it interests you, but it's pretty interesting to me. The next thing we're going to add to the system is what's called homomorphic encryption. So homomorphic encryption is a very, very fascinating and very, very bleeding edge, research topic in cryptography. It's a form of cryptography that allows you to encrypt data in such a way that you can perform mathematical functions on top of the encrypted data, right? The encrypted data is called ciphertext, often we call it cipher. And you can actually do mathematical operations like addition and subtraction on the ciphertext in such a way that when you decrypt the data, those mathematical operations are respected, they're preserved. So if you encrypt the number 3 and then take the cipher, that result, and multiply it by 2, and then take that and then decrypt it, you'll actually get 6, right? This is not normally, you can't normally do this in most forms of cryptography, right? Or you could do addition and so on. And it turns out first of all, like this kind of cryptography has only existed really for a few years. Like maybe 20 years ago, we came up with a basic way of doing it, but it worked a billion times too slow. Like it was literally many orders of magnitude slower than conventional cryptographic means. So it was impractical to use for most things. Now it's only like 1,000 times as slow as, I'm actually making these numbers up. I don't know the exact numbers, but let's say like it's improved a lot, but it's still very costly. But it's become realistic to do for certain kinds of operations, right? So now, imagine you take this kind of encryption, and now we're going to work it into the system. And by the way, this is what Numerai uses homomorphic encryption too. So here's what's going to happen. AI Incorporated is going to generate a public and private key, which is used for the homomorphic encryption. They're going to encrypt the model with the homomorphic encryption. Now the model's weights are red, right? This means it's encrypted. So it's encrypted it, and it then sends those encrypted models to the users. And the encrypted models can still actually, because they're homomorphically encrypted, they can actually still perform all the operations of a neural network and generate an output that is useful to the user. So what happens is, they generate the output. The users can now use these homomorphically encrypted neural networks, except now they can't actually steal them, right? But otherwise, everything works exactly the same. User gets the service, sends gradients back to AI Incorporated. AI Incorporated can then train the model, and then go on about, using, send the new network, the updated model to it, and business as usual. Right? So selling access to the model. Now so what are the pros and cons here? So now you might be thinking like, okay, now privacy is really preserved, right? Because now actually like the gradients are also encrypted, right? Well, it turns out this is not fully true yet, because it turns out also, and this is now getting into really obscure stuff, but in machine learning, you can design a model in such a way that that all it's actually doing is it's just copying the data and copying it into the model itself and sending it back to AI Incorporated. And now, because the model is encrypted, there's no way for the users to find out that that's happening. So a malicious AI Incorporated could still steal the data. Now, however, the model is now cannot itself be stolen by the users, so at least that's a nice thing. And then the lost natural income still remains, right? We haven't solved that yet. Okay. Now getting more complicated. I told you this is going to get crazy. So now add a smart contract to the mix. Here's how it works. AI Incorporated, as before, generates a public and private key to encrypt the data, to encrypt the network, encrypts the model, and puts it into a smart contract. Now the smart contract has the model, and it's encrypted. And it also puts in some money, some cryptocurrency, let's say, into the smart contract. And now the smart contract is separate from AI Incorporated. It's on the blockchain, entirely public. It's encrypted. The model is encrypted, so it can't be stolen. But now, rather than AI Incorporated doing all the processing is done in a smart contract which is separated from AI Incorporated. So now the smart contract will send the encrypted model to the users. The users have the model. They receive a service, generate gradients, and then what happens is the smart contract will pay them for access to that data. Right? So that's kind of that's a new thing. Users now being paid for generating data, for generating the gradients after they've been verified somehow. And then the smart contract will take those gradients, add them to the network, send it back to AI Incorporated. AI Incorporated will decrypt it and train it, and then again profit. Right? There's the business model. So what's happening here now? Now we can safely say that the user's privacy is entirely guaranteed. And the reason why it's entirely guaranteed is because, as I mentioned before, that you can learn a lot about the users from the gradients that they submit, right? But the gradients no longer go to AI Incorporated. They only go into the smart contract, where they are mixed together and added to the network, and then once they're mixed together, once all these gradients are added together, there's no more way of reconstructing information about any individual user. We don't know of any way of doing that. So now we know that we can actually guarantee users' privacy in a system like this. And that's really new. Like, that doesn't exist in any real machine learning system that I know of, where you can truly respect people's privacy. And of course, like, that will have far-reaching implications we'll get into in a second. But going back to the pros and cons, privacy is maintained. Another nice thing is now the users are compensated for the data. So now this is really the economic model that the internet should be based on, right? When you create data, you are performing a service, right? You are doing some labor, and users can be compensated for it. Can you hold questions to the end? And then, yeah. Now, and the model is also secure from theft, right? The model is secure from theft because it's encrypted, right? That's been there since before. Now, there's still one more problem. And we're going to have to introduce like one more complication to make it work, which is who holds the keys, right? So like here I actually put the keys into AI Incorporated, right? But that doesn't, like, this wouldn't work, right? Because then actually all of this falls apart because AI Incorporated could then, smart contract is public, so they could at any point, like let's say after one user has submitted the gradients, they could download the model, decrypt it, and then do the differential privacy stuff to determine what the user's data is. Right, so AI Incorporated cannot actually be trusted to hold the keys. So who should hold the keys? Well, you can't put it on the smart contract itself because then anybody can decrypt it. So users can steal the data, AI Incorporated can spy on them, and so on. Or maybe someone, totally outside the whole system can steal it. So who should store the keys? Okay, so now we're going to add one more feature, and this is called an oracle. In open mind parlance, it's called a capsule, which implements what we often call an oracle in the blockchain space. What an oracle is it's kind of like an insurance company. It performs the service of protecting the keys that are used for this entire process, right? And the oracle has to put up it's like an insurance company. They have to they have to stake a large amount of money for the privilege of protecting these keys. And if they do a good job, they get paid a little bit, right? And if they do something malicious, like steal the keys, they lose a ton of money, right? So it's basically like an insurance company. It's like a guardian of the keys, right? And so here's how it works. This is the final model. AI Incorporated sends a blueprint of the network, like an untrained network, unencrypted, to the oracle. Now, it's important that this is done publicly because now this prevents the problem that we mentioned before, that a malicious AI Incorporated could potentially steal users' data by making the model such that it simply just copies data surreptitiously, right? So now, because everyone can see this process, it can be verified that they didn't do that. So they put it into Oracle, they generate the keys, and they transfer the public key. And this is not a homomorphic key. This is just a normal, like, RSA key. They send it to the capsule. Capsule has the public key of AI Incorporated. And then Capsule generates its own keys that are secret from everybody. And these are the keys that are used to perform the homomorphic encryption. So now Oracle will encrypt the model with its private keys, homomorphically encrypt it, send the model to the smart contract. Everything else is the same, basically. And then the money goes from AI Incorporated to the smart contract. Smart contract sends the models to the users. Users have the model, get the service, give gradients back to the contract. Contract adds those gradients together, pays the users, sends the model back to the capsule. The capsule will decrypt the model, and then it will decrypt it with the homomorphic key, right? And then it will re-encrypt it, it will train it. Actually, I think this is wrong. I think it gets trained inside here. I have to double check. But basically, the main idea is that it decrypts it, and then it re-encrypts it with the public key of AI Incorporated, and then sends the encrypted model back to AI Incorporated. It has the final model, which it can then decrypt with its private key, right, which no one ever saw. Now, this process is fully transparent, what's happened, except at no point anymore are any of the privacy boundaries violated. So none of the users ever saw the weights or can ever steal the model. AI Incorporated never has any way of decrypting the model and stealing people's gradients or stealing people's data. And so what's happened is AI Incorporated was able to train the model in a fully blind way. They don't know anybody's data, so they can perform a service to that user without knowing anything about them, which is really powerful, right? Like, imagine we were talking before about this notion of sensitive services, right? And they're sensitive for the simple reason that the company is entrusted to know information about that user, which is possibly very sensitive. Now it can actually perform a service without knowing anything about a user, which is really unprecedented. Pretty cool. And of course, business as usual, AI Incorporated can sell the model, so on, so it preserves everything. Okay, so now we have everything, right? Users maintain the data, privacy is maintained, users are compensated, the model is secure from theft, the keys are secure, and everything, right? So this is kind of an ongoing project. And for anyone who's interested in it and wants a really much better explanation of it, I highly encourage you to visit their website. There's a lot of information how you can get involved. Okay, so this is like the last couple slides, and now I just want to pose some questions to you, right? So now I want to, like, this is kind of like my ruminations about this, like, about both like what we saw, in particular with Numerai and with an open mind. Like, could you have a system in which all of the users are equivalent to AI Incorporated? In other words, there's no difference between these users and AI Incorporated. You have a pool of users which agree to train a model which is decentralized that performs a service for them. And they'll all be paid for it, right? And they're willing to actually stake money into it because the model performs a valuable service to them. So now you have maybe a means of having a machine learning model which is effectively a public good, like a public utility that's shared by everyone. And you can possibly use cryptography to enforce that no individual person can actually co-opt the model and use it for something else, possibly storing it as a shared secret or something like that, like a fancy cryptographic scheme. There's lots of research into how these kinds of things can be implemented using fancy cryptography, multi-signatures, like oracles and things like that. But like the question that I have is, and I don't really know actually, I don't know enough about it to answer one way or the other. Can the users be equivalent to AI Incorporated? Could the model be a shared secret? If it is a shared secret and it's hosted autonomously, and if it's hosted as a shared secret, can it be made to run autonomously? If it's on a smart contract on a blockchain, it'd be performing a service entirely autonomously. And can those models then control their own resources? So the model has a notion of money that only it has in its wallet, and it can pay users to give it data, and it can also sell its services to license it to third parties. And so that's a way of getting money into the system. So in other words, can you have a machine learning model which is a completely decentralized service provider that manages its own resources, right? And then the last thing and this is like on my mind, is like, could it be an artist also? Like there's lots of these algorithms that are developing machine learning art, machine learning based art, that's a big interest of mine. So like, what if it were doing that, and it were generating art, and it were selling it, like in an open marketplace, like it's art can be sold. And this actually was written about by Trent McConaughey, who's actually started the Ocean Protocol. And here's one recipe towards this. And it's a pretty simple one. You can imagine much more elaborate ones, but imagine you have a decentralized autonomous organization which is hosting a machine learning model, which creates generative art, makes multiple editions of them, timestamps them, like declares copyright, sells them on some, possibly on even centralized services, or maybe like an open bazaar or whatever, and then transfers the rights to the content to the buyers. It gets paid, has its own wallet, right? It uses the proceeds to pay for the computation to actually make the thing, and then maybe like, what does it do with the money, right? Like, well, maybe it just pays the creator, which is kind of boring, right? Or maybe it just begins to accumulate money. So like the question is, can you have a machine, like an artist, this decentralized autonomous organization, which isn't generating art, accumulating its own wealth? Can it do that? Can it become a millionaire? Like, can you have this entity which is acquiring wealth on the blockchain that's totally separate from from everyone, right? Which is a really, really crazy thing, but possibly, like actually realistic. And then this gets into the question of like, okay, well, if you have an entity which has its own resources, like who's involved? Like, do we have the legal infrastructure to actually do this? And it turns out that in some places we do, right? So this is a picture from a city in Switzerland called Zug, which has been nicknamed by the blockchain people Crypto Valley. And it's called Crypto Valley because it has some laws that are particularly eccentric. It allows you to register corporations that effectively have no people in them. You can have a corporation that has 0 people. And we know, and by a corporation I mean truly a corporation that has all the legal rights of corporations that are given to them. So if that's true, you can have a corporation with 0 people. Can that corporation, and by the way, like this is where all the ICOs are happening, in like places like this, because of course it has all the laws that are necessary to have decentralized autonomous organizations that function as companies. So if you can have this, and you can have a corporation with 0 people, accumulating its own wealth, doing all the things that we associate with humans, like is that feasible? Are there any legal barriers to it? Can it be made to comply with the law? Can it be entirely autonomous of people? Right? So this seems to be a case that we have all of the technology and legal infrastructure is in place for personless entities to have rights that are respected by legal systems in the world. So this is kind of a very, very new thing. And I suppose maybe it remains to be seen what we do with this, or whether or not any of these things ever pan out. I just wanted to plant that seed in your brains, whether these kinds of things can be made to work, and if they can, what should they do, right? So I use art as an example because art is this kind of thing that everyone responds to, right? But they can do all sorts of things. They can do also things that we don't like, right? And that's kind of important because. And that's why I want to be in this space, despite maybe ethical reservations about what these kinds of entities can be made to do, because what they do is really up to us, right? They can be made to do the most progressive things in the world, and they can be made to do the most evil things in the world. And we haven't talked about the evil ones, right? But there's no reason why they can't do any of the things that people do. And so this is a very double-edged sword. And so it's really sort of up to us to build it, right, in a certain way. So that's all I have for you. I'll kind of stick around if you guys have some questions. And for those of you who are coming on Sunday, the workshop, we'll talk about this in much more detail. I hope you can join us. And that's all.